Pistachios are quietly stepping into the spotlight as a potential functional superfood, and the latest microbiome research gives compelling reasons to take notice. Unlike ordinary snacks, pistachios offer a combination of nutrients and bioactive compounds that appear to work synergistically with our gut bacteria, producing effects that ripple far beyond the digestive tract. They are rich in fiber, unsaturated fats, plant protein, and polyphenol, an unusual mix that allows them to feed beneficial microbes while also providing substrates that modulate blood sugar, lipid metabolism, and inflammatory pathways. The notion of functional food implies that a food delivers measurable health benefits beyond basic nutrition, and pistachios increasingly fit that description, particularly as science uncovers how they shape the gut ecosystem in ways that support metabolic resilience. Recent studies suggest that regular pistachio consumption increases populations of bifidobacteria and lactobacilli, key bacterial genera associated with healthy gut function and metabolic regulation. These microbes ferment pistachio fibers and polyphenol into short-chain fatty acids, including butyrate and acetate, which strengthen the gut barrier, reduce local and systemic inflammation, and enhance insulin sensitivity. In other words, pistachios do more than simply pass through the digestive tract. They actively feed a microbial community that then communicates with the liver, fat tissue, and even the brain to influence glucose metabolism, appetite, and inflammatory signaling. This positions pistachios as a food that can contribute to metabolic health in subtle but meaningful ways, helping to reduce risk factors associated with obesity, type 2 diabetes, and cardiovascular disease. The impact on blood sugar is particularly intriguing. Compared with other carbohydrate or sugar-based snacks, pistachios have a low glycemic index and are absorbed slowly due to their combination of fat, fiber, and protein. This slow absorption blunts postprandial glucose spikes and reduces insulin demand, which over time may support better glycemic control. Moreover, the fermentation of pistachio fibers in the colon produces SCFAs that enhance insulin signaling and modulate glucose production in the liver. The dual mechanism, both direct nutritional effects and microbiome-mediated metabolite production, makes pistachios a uniquely strategic snack for metabolic balance, especially when incorporated consistently into a diet rich in whole, minimally processed foods. Inflammation, a silent driver of many chronic diseases, is another area where pistachios shine. Polyphenol and other bioactive compounds in pistachios are metabolized by gut microbes into smaller phenolic metabolites, which exert anti-inflammatory and antioxidant effects. These compounds can downregulate inflammatory pathways both locally in the gut and systemically, potentially reducing markers like CRP or IL-6. By supporting a healthy microbial community and generating metabolites that actively counter inflammation, pistachios bridge the gap between food and functional medicine, turning a simple snack into a potent ally for long-term health. Scientific nuance adds to the excitement. Individual responses vary, and the baseline composition of one's microbiome influences how effectively pistachios can promote SCFA production or polyphenol metabolism. Yet this variability doesn't diminish their value. It underscores the idea that pistachios are a flexible, accessible tool for cultivating gut diversity and metabolic resilience. They can be enjoyed in small, daily servings without the need for restrictive diets, specialized supplements, or complicated interventions. Over time, their integration into a balanced diet can gradually nudge the microbiome toward a composition that favors metabolic health, reduced inflammation, and improved glucose control. The broader implication is that pistachios exemplify a new paradigm in nutrition, foods as active agents in human physiology, not just passive sources of calories. By harnessing the interplay between dietary fibers, polyphenol, and the microbiome, pistachios offer a model for how common, enjoyable foods can deliver functional benefits traditionally sought from supplements or medications. Their versatility, usable as a snack, incorporated into meals, or blended into smoothies, makes them an easy and sustainable way to support gut health and systemic metabolism. In sum, pistachios are more than just tasty nuts. They are emerging as a functional superfood with scientifically plausible benefits. They feed beneficial bacteria, enhance SCFA production, improve blood sugar regulation, and reduce inflammation, creating a cascade of positive effects that extend from the gut to the entire body. Regular inclusion of pistachios in a balanced, fiber-rich diet could help cultivate a resilient, metabolically healthy microbiome, making them not only a delicious treat, but also a strategic tool for long-term health and wellness. They illustrate how thoughtful, evidence-based food choices can become proactive, enjoyable steps toward preventing chronic disease and supporting everyday vitality.